Hello friends, this video is about the chapter Electricity, chapter 12 from class 10 science textbook. Okay, let us start electricity. It is included under physics section. So electricity is also known as electric current. So current means flow. We all know that like water current means flow of water. So electric current means flow of electrons. So in earlier videos also I have already mentioned about electrons. I have gone through the presence of electrons inside the atoms. So in this video I am also giving again the concept of electrons. So let us consider an atom. So I am going to draw an atom. So for atom, inside the center of the atom we find nucleus. So we all know that nucleus is positively charged. That's why I have written here plus. Now why the nucleus is positive? Question comes here. Why the nucleus is positive? Nucleus is positive due to the presence of protons inside the nucleus. Protons are present inside the nucleus. So if there are 3 protons, then the charge of the nucleus will be plus 3. If there are 4 protons, the charge of the nucleus will be plus 4. Inside the nucleus, along with protons, neutrons are also found. But neutrons do not have any charge. That is why they are neutral. So if we are considering the charge, we don't take neutrons because they are neutral. So if we are taking or talking about charge, then we will consider only protons. So inside the nucleus we find protons and neutrons, but outside the nucleus we find electrons which revolve around the nucleus, in orbits, in shells. Okay, if there are 3 protons inside the nucleus, there will be 3 electrons outside the nucleus. So here I have drawn 1, 2, 3, 4, 5 electrons outside the nucleus. So there must be 5 protons inside the nucleus. So that for 5 protons plus 5, for 5 electrons minus 5. So overall the charge of the whole atom is 0. Now here the outermost electrons. So you can see here 2 orbits. The outermost orbit is this one. If I draw 3 orbits, the outermost orbit will be 3rd orbit. If I draw 4 orbits, the outermost orbit will be the 4th orbit. So the outermost orbits, the electrons which are present in the outermost orbits are known as free electrons. Remember here in this case the free electron is this one. Okay, now why they are called as free electrons? Only this electron is free because this is present in the outermost orbit. So this is outermost electron or free electron. These electrons are not outermost. So this are outermost electrons. They are known as free because the attraction is less. I am repeating again, the attraction will be least on the outermost electron. This is proton, this is 1st orbit, 2nd orbit, 3rd orbit, 4th orbit. Here is an electron, here is an electron, here is an electron, here is an electron. Now just use your brain and think that where will be the most attraction. Attraction means the attraction between positively charged nucleus and negatively charged electrons. So here will be attraction the most. Here will be the attraction the most because the distance is least. More the distance, least the attraction. So here attraction is least. So if attraction is least, therefore the electrons will be free. They can move freely, but these electrons cannot move freely. Only this electron can move freely. So this is a conductor, right? This is a conductor, metallic conductor. So when we apply potential difference, means when we apply a source like battery or generator, anything, source. So when we apply potential difference, these free electrons move. This is positive end, this is negative end of the battery. So electrons will move towards positive end. Okay, clear? The electrons will move toward positive. Which electrons? The outermost electrons, the free electrons. Okay, so the direction of the flow of electron is this one. Because electron is negative, it will move towards positive end. Direction is this one. This is the actual direction, but in books we find that the direction is from positive to negative, like this one, from positive to negative. So this is the conventional, means we follow this direction, but actual direction is this one. Towards positive. But conventional direction, when we draw, we give this direction. Clear? Next, circuit. Now what do you mean by circuit? Circuit means path, closed path through where electrons, means free electrons, can flow, giving us electric current or electricity. So the path is closed. The path must be closed to get the electric current. So, but all the time we don't want our circuit closed. Means sometimes you want your light switched off. You don't need your light switched on. So in that case, the circuit must be broken down and again reunited. So in that case, we find key, which sometimes closed the circuit and sometimes opened the circuit. When it is opened, the electron cannot flow. When it is closed, the electron can flow. So this is ammeter. Ammeter means it can measure the current. The current is more or less or how much. That current can be measured by this ammeter. So this is the appliance. In this case, it is light, a bulb, it may be a fan, it may be a TV, it may be a refrigerator, anything, appliance. Now here is the relation between current, charge and time. Okay, charge. We always say here that flow of charge means flow of electrons only, because electrons have charge. We all know that an electron, the charge of an electron is minus 1.6 into 10 to the power minus 19 Coulomb. Remember, the charge of an electron is minus 1.6 into 10 to the power minus 19 Coulomb. So flow of electron or flow of charge, the unit of charge is Coulomb, and divided by time. Time is given, the unit of time is second. So unit of current is ampere, unit of charge is Coulomb, unit of time is second. So we can define 1 ampere current. 1 ampere current means flow of 1 Coulomb of charge. Flow of 1 Coulomb of charge. It is not saying that 1 electron. Flow of 1 Coulomb, not 1 electron. Flow of 1 Coulomb, not this Coulomb. 1 Coulomb. Flow of 1 Coulomb electron in 1 second. The current will be 1 ampere. If it is flow of 2 Coulomb of 2 Coulomb of charge in 1 second, the current will be 2 ampere. Clear? Okay. Now this ampere, the current concept and the unit ampere, this concept was given by Henri-Marie Ampere. He was a French scientist. He gave first the concept of current. So in honor of his work, the name has been given ampere. So I have already told you, flow of 1 Coulomb of charge. It does not mean flow of 1 electron. Flow of 1 Coulomb of charge does not mean flow of 1 electron. So what is the relation between 1 Coulomb and charge of one electron. So charge of an electron is minus 1.6 into 10 to the power 19 Coulomb. It is very much lesser than 1. Remember, 1 is very much larger than this one. So in 1 Coulomb of charge, it equals to charge of 6 into 10 to the power 18 electrons. So if you have in your hand 6 into 10 to the power 18 electrons, then only you will have charge of 1 Coulomb. But if you have only 1 electron, you will have only this charge, minus 1.6 into 10 power minus 19 Coulomb. Clear? So this is the relation. 1 milliampere is 10 to the power minus 3 ampere. 1 microampere is 10 power minus 6 ampere. 6 ampere. So next we have electric potential and potential difference. So here you should grab the concept of electric potential and potential difference, because if you don't get the concept here, you will not understand the latter part of the chapter. So electric potential. For this, consider a waterfall. Consider a waterfall. So water is going down. Okay. Now think, if height is more, so this is a case, this is a case. Here is a height, here is a height. We can see that here the height is more than this one. Okay. So naturally, more the height, more will be the flow, more will be the pressure. Lesser the height, lesser will be the flow. Lesser will be the flow. So height, more will be height. Height, here is height, here height is not more. Here the difference of the height is more. Remember, it is height 1, it is height 2. So the difference is h2 minus h1. Here it is h3, h4. In this case, the difference is h4 minus h3. So I can say that h2 minus h1 is larger than h4 minus h3. Clear? So height is potential, h1 is potential, h2 is a potential, same h3 is a potential, h4 is a potential. To get the electric current, you must have the difference. Like if there is no difference in height, h1 and h2, there is no difference in the height, same height. So there will not be any flow of water. You cannot see flow of water because there is no difference in height. To get the flow of water, there must be difference in height. So in the same way, to get the flow of electrons, flow of charge, there must be potential difference. So electric potential, like a battery, you can see the positive terminal and negative terminal. The positive terminal, the unit of potential is, remember, volt. Suppose the positive terminal has volt 5 volt. Positive terminal 5 volt. Negative terminal is again 5 volt. Then the difference is 5 minus 5, 0. So this battery cannot produce electricity because there is no difference. Okay. If the positive terminal is 10 volt and negative terminal is 5 volt, then the difference becomes 10 minus 5. The difference becomes 5. Then there will be flow. So more the difference. So this is a battery having 5 volt of potential difference. This is a battery having 10 volt of potential. 15 minus 5, 10 volt of potential difference. Here potential difference is 5 volt. Here potential difference is 10 volt. Here is the potential difference is more. Therefore here you will get more electric current. Clear? So potential difference must be there to get the electricity. So potential difference is equal to work done divided by charge. Remember, work done divided by charge. Work done unit is joule. Charge, we all know that the unit is Coulomb. So potential difference unit is volt. So 1 volt equals to 1 joule by 1 coulomb. So actually what is the concept here? 1 volt of potential difference may be defined as the potential difference between the two terminals of the conductor to do work done of 1 joule to travel 1 coulomb of charge. Means this is a conductor. You have 1 coulomb of charge and you need to flow 1 coulomb of charge. You need to flow 1 coulomb of charge. For the flow of 1 coulomb of charge, you need to do work. So you need to do 1 joule of work. You have to do 1 joule of work to travel 1 coulomb of charge in a conductor. So you need to give a potential difference of 1 volt. Clear? To flow 1 coulomb of charge, you have to do work of 1 joule. Thereby, you have to give potential difference of 1 volt. If in a conductor to flow 1 coulomb of charge, if you are doing 10 joule of work, if you are doing 10 joule of work, then the voltage will be 10. The potential difference, the battery must be of 10 volt. Clear? So this is the relation, mathematical relation. So again, this potential difference concept was given by Alessandro Volta. He was an Italian physicist. Okay. To measure the voltage, a device is used known as voltmeter. To measure the current, we had ammeter. To measure the voltage or potential difference, we have voltmeter, which is attached as parallel connection. Okay, parallel connection means this is the circuit. Parallel connection is this one. If the ammeter is connected here, so this is series connection, but this is parallel connection. Voltmeter is connected in this way. Now we have Ohm's law. It was given by George Simon Ohm. He was a German physicist. He said that if you increase the potential difference, the current will automatically increase. Yes, I have told you already. If you increase the potential difference must be increased, not the potential. You are increasing the potential. Here you are increasing. If you make it 15 to 20 and if you make it 5 to 10, the difference is again 10 volt. So you can increase the potential, but the important point is that you need to increase the difference. Potential difference must be increased to get more current. So potential difference is directly proportional to I, current. So we all know that to remove this proportionality, we can multiply I by a constant. R is constant known as resistance. Resistance means resist. It is the property. Of a conductor to resist flow of electrons. Remember, it is the property. Resistance is the property of a conductor. Means through this conductor 1 coulomb of charge or any coulomb of charge, means electrons are flowing. The conductor is resisting the flow. It does not want its electrons to be flown. So this property of the conductor is the resistance. So V equals to IR. The unit of resistance is ohm. So okay, this much is enough in this video. If you have any doubt, then you can directly contact me or give in a comment section. I will answer you in the later part. Okay, in the next video we will be coming with the next part of the chapter. So till that time, thank you very much.